All right, should have already done on assignment 7-1. You should have done problems number 5 and 6. Those were your homework. If you haven't done them yet, do them before I show you how to do them. You should practice them. If you're stuck, great. We'll do it. First question is, what's his angular velocity? Angular velocity is equal to the angle you travel through divided by the time it takes to do it. Every 1 second, he travels one full circle. One full circle in terms of radians, where we need to do angular velocity radians, is 2 pi. So that's going to give me 6.28 not meters, because it's angular velocity, it's radians per second. And that's how I got that answer. And then on B, I want to know my linear velocity. Linear velocity is equal to angular velocity times radius. Or you could have done 2 pi r, one trip around, divided by the time it takes to do it. Either way, you're going to get 6.28 times the radius, and the radius is 2 meters. So that's going to give you 12.6 meters per second. And then C says, all right, if that's the case, what is the centripetal force? What's the force of tension in his arms? Well, the way we're going to find force of tension in the arms, what is the arms doing? So arms are forcing him to go in a circle. So force net equals the sum of all forces, and he's making it go in a circle. So the net force is force centripetal, which is equal to the electric field, is equal to the sum of all forces. So sum of all forces, the only force on him is force of tension. That matters in left-right direction. Okay, and so the force of centripetal is mv squared over r is equal to force of tension. We just found the velocity, so the mass of the lion is 300 times 12.6 squared over the radius of these arms, which is 2, is equal to force of tension, and I get, by throwing that in the calculator, 300 times 12.6 squared divided by 2, and I get 23,800 newtons, which would be quite incredible and probably beyond what any human could be, even a comic book character. All right, if you have got 6 done and you feel good about these answers and have 6 already done, go ahead and keep going. If not, please hit pause. Try problem number 6 now, and then we will jump on it together in just a moment. All right, now number 6 is equal, in the book Tarzan really uses a sling. He slings this rock horizontally, which means he's not worried about gravity too much. He's not worried about gravity too much. So I'm going to grab an eraser here because it's weird that he has 3 legs. All right. So he's using a sling. So the sling is going to be, and that's what the force of tension in the rope would be, right? Maximum, actually says maximum tension, that's 1,000 newtons. And it wants to know how fast can he whirl this thing around his head. So we note that F net equals the sum of all forces, and in this case, it's going in circles, so the net force is going to be force centripetal. That's equal to the force of tension, the only force that matters. And then force of tension maximum is 1,000, so that's the maximum you can put on there. Force centripetal is going to be equal to mv squared over r. The mass of the thing we're whirling, well, the thing we're whirling is a rock, so that's 0.5 times v squared. So that's going to be what we're looking for, v squared over the radius, which is we're whirling it in a radius of 0.7 meters, because that's how long the rope is. Probably have to add some arms onto that, but let's not worry about that right now. So that's 1,000 times 0.7 divided by 0.5 is going to give me that v squared equals 140. Take the square root, and you get the velocity. A reasonable velocity would be 11.8 meters per second. Okay. All right, so that handles that. Okay, with that in mind, go ahead and hop on 7.5. Try problem number 1, and then I'll do problem number 1 right behind you. All right. Here we go. Move forward. All right. So Bob swings a yo-yo. Mass at the end is 0.430 kilograms. He has a length of 0.7 meters. And he's swinging it horizontally with a speed of 30 meters per second. What is the force of tension in the string? Again, force F net equals the sum of all forces. Since it's going in a circle, his force that he needs is force centripetal. So that's got to be his net force when he's done. Otherwise, he's not going in a circle. So then that's going to equal the force of tension. So that's mv squared over r equals force of tension. So the mass of it, we said, was 0.430. His velocity is 30 meters per second squared divided by the radius, which is 0.7, equals force of tension. Throw that all in my calculator and see how fast you get to whirl that. It's 0.4 times 30 squared divided by 0.7, and I get a whopping 552 newtons. 553 newtons. All right, so with that in mind, go and do 2, then do number 3. I'll meet you on the other side of number 3. We'll do number 3 together just to make sure we know what we're doing. Oh, wait, no, I'm lying. We got to do 2, 3, and 4 together. So go ahead and do 2, 3, and 4, and then I'll try to jump in behind you and do 2, 3, and 4 with you in just a moment. All right. All right. So that would be my grandson. So calculate the centripetal force of a 10-kilogram boy is sitting on the edge of 4 meters from the center of a merry-go-round. The boy is running around the outside, pushing it at 5 meters per second. So F net equals the sum of all forces. We take a look at this one. It says, what's the centripetal force? So I might as well just go straight to force centripetal formula. That's mv squared over r is equal to the mass of the boy, which is 10, his velocity, which is 5 squared, and it's divided by 4, for that's the radius, and I'm going to get 10 times 5 squared divided by 4, and I get 62.5 newtons. So that's how much force he needs in order to go in a circle. Okay, so what's causing the centripetal force? If a boy's sitting on the edge of the thing, it's flat, it's level, what could possibly be causing it? So I've got this, I've got the boy sitting on the end here, bored. What's keeping him from falling off the thing? The only force I can think of that makes any sense at all would be force of friction. Pushing him towards the center because he wants to keep him from moving. So since he's on a horizontal surface, what's the minimum coefficient of friction needs to pull this off? Well, F net equals the sum of all forces. Okay, F net is equal to force centripetal. And that's going to be equal to, what do I got going? I've got force of friction, the only thing holding him in place, right? So I'm going to go mu force normal, because that's the force of friction formula. And we already solved for the centripetal force, and it's 62.5 newtons in this case. So we're looking for mu, don't know what mu is, but I do know force normal is going to be, since it's on a horizontal surface, it's going to be equal to his force of weight. How hard he pushes down is how hard he gets pushed up. And that's going to be 10 times 9.8 equals 62.5. So his minimum static, because he's not moving, 62.5 divided by 98. And I get a whopping minimum mu static would be 0.638. It should be noted that if he breaks static, he's going to accelerate fast because his kinetic friction is going to be less, and so he's going to have a much larger, so he's going to lose his ability to stay in place very fast, and he'll probably end up going in a straight line off the edge of the merry-go-round. All right. Or you should probably hold on, which probably make more sense. Okay, keep doing problems. You got to do 5 through 7. I'll catch you at 7. Okay, I'll catch you at 7. So make sure you know, so actually 7, 8, 9. All right, so do 7, 8, 9. I'll catch you at 7, 8, 9, and then we'll be done with this worksheet. All right. All right, you should be on number 7, 8, 9. So let's do 7, 8, 9. So take a look at 7, 8, 9. I've got sling, rock, mass 0.500 kilograms. On the end of a 1.20 meter long string is whirled over the boy's head such that each complete rotation is 0.160 seconds. What's the speed of the rock? Okay, so one quick thought about this whole thing is it's got to be horizontal. I haven't told you otherwise. probably should ask this question, probably should say so in the problem, but I'm going to say it's horizontal, in which case it's going along horizontally around the person who's going like this. It's over their head. Apparently he's swinging it like this in a big circle over his head. Okay, fair enough. All right, with that in mind, the first question is, what's the speed of the rock? Okay, well, if it's going, so probably the quick way to do this would be 2 pi r over t. Again, one trip around divided by the time it takes to do it. One trip around, that's the circumference of a circle, so that's how far it goes divided by the time it takes to do it. And then, so that's 2 times pi times 1.20 every 0.16 seconds. And so I'm going to get to the speed as 2 times pi divided by 1.2 divided by 0.16, and I get a whopping 32.8 meters per second. Okay. Once I have that, that's what's the acceleration? What acceleration? Remember, is always accelerating towards the center. So we're talking about centripetal acceleration. So that's v squared over r, and the velocity is 32.8 squared over the radius, which is 0.16. So that would be squared divided by 0.16, and I get a whopping 6,690, what's units? Meters per second squared. So we're accelerating quite rapidly. If you were on that rock, you would be very uncomfortable with life. Tension, what's the tension in the rope? Well, tension is equal to force centripetal, because it's what's providing the force centripetal, right? So that's going to be mv squared over r equals tension, right? And then v squared of r is what we just solved for. That's the tension, and the mass of the object is 0.50. So 0.50 times 6690 equals tension. So times 0.5, and I get a whopping 3350 newtons. Okay? All right. That should take care of you for assignment number 7.5. Next thing you should do is you go 7.6. I should go back to 7.1. Try problem number 7. Try problem number 7, and then I'll catch you on the backside over there.